On November 16, 1974, for about 3 minutes, humanity did something it had never done in 300,000 years of existence. It spoke first. A radio telescope in Puerto Rico fired 1,679 bits of deliberate code at the globular cluster M13, 25,000 light-years away. And right now, while you sit wherever you're sitting, that message is still in flight. A thin thread of human noise crossing a gulf no person will ever survive. We sent it the way you'd mail a letter to someone older and wiser, half hoping they'd write back and explain the universe to us. Because that's the story we've always told ourselves. 13.8 billion years of cosmic time. Civilizations rising and dying before Earth even cooled. And us, the newcomers, the latecomers, finally grown enough to step outside and ask the old question, where is everybody? It's a reasonable assumption. It might also be exactly backwards. What if we aren't the ones meant to be listening? What if, in this story, we're the ones being heard? This is the Firstborn Hypothesis, and it changes which end of the story we're standing on. Start with the assumption itself, because it's a good one. Mind die Orstiburiken die, to by taste to The universe is ancient. We are not. The sun didn't ignite until the cosmos was already more than 9 billion years old. So somewhere out there, surely, are species who got a head start measured in billions of years. Civilizations so old that we're the infants in the room, scanning the dark for the grown-ups. That's the Fermi paradox at its most pessimistic. And honestly, it feels less like a theory than plain common sense, but that's where the common sense breaks. In October 2015, Peter Beruzzi and Molly Peoples at the Space Telescope Science Institute ran the actual census, not of the planets that exist now, but of every habitable world the universe will ever make, across its entire lifespan. The number they landed on is quietly staggering. When the Earth formed 4.5 billion years ago, only 8% of the potentially habitable planets that will ever exist have been born. So inti per increase percent. The other 92% are still coming. Most of them haven't formed yet. Beruzzi put it plainly. Compared to all the planets that will ever form in the universe, the Earth is actually quite early. Sit with what that means for you specifically. Every ancestor you've ever had. The first human, the first mammal, the first cell that ever copied itself in a warm sea, all of it happened in the opening minutes of a party that runs for trillions of years. You didn't arrive late. You and your entire lineage walked in before almost anyone else. So if we're early, the next question writes itself. How early? And the answer is stranger than the census. In August 2016, Avi Loeb at Harvard, working with Rafael Alves Batista and David Sloan at Oxford, asked a simple thing. Across all of cosmic time, past and future, when is life most likely to appear? Not when did it. When is it most probable, weighted across the whole lifespan of the universe? Their model points to a moment almost incomprehensibly far ahead, around small, dim red dwarf stars, stars that burn slow and last nearly forever. Life becomes most likely not now, but something like 10 trillion years from now, 1,000 times deeper into the future than the entire present age of the universe. Now, this is a model, not a verdict. It leans on assumptions about those dim stars we haven't confirmed. But follow the logic, because it's vertiginous. If the great age of life lies 10 trillion years away, then the beings who arise in it will look back through their telescopes and their fossil record toward the dawn of everything. They'll search their sky for the first ones, the ancients, the originators, and they'll be looking for us. The elders we keep scanning the dark for may not exist yet. We're not waiting in the audience for them to arrive. We're auditioning, right now, for the role of the ancient ones in someone else's sky. But maybe you're thinking, fine, the cosmos is young. That doesn't mean life is fast. Maybe life is rare and slow, and we just got freakishly lucky to be here at all. Here's the part that closes that door. Look at the rock under Western Australia. In the Dresser Formation sit stromatolites, layered structures built by living microbial mats, dated to roughly 3.48 billion years old. There's an even older contested claim, around 3.7 billion years, from the Isua Belt in Greenland, though geologists still argue over whether that one is truly life or just mineral mimicry. But the 3.48 billion year mark is solid, and here's its weight. The Earth was barely cool, barely done being bombarded, barely able to hold liquid water, and life was already here. Not a latecomer waiting billions of years to show up. It arrived almost the instant the planet could keep it. So we know life came early in the universe, and early on Earth. And now the honest part? The thing we cannot tell you. We can date life's first appearance with rock and radiometric precision. What we still cannot explain is how it happened at all. The jump from lifeless chemistry to the first thing that could copy itself. Abiogenesis has never been reproduced in any lab, never fully accounted for in any theory. We know the moment. We don't know the mechanism. And that single unanswered question is what keeps a very old, very serious idea alive. In 1973, Francis Crick, who co-discovered the structure of DNA, and the chemist Leslie Orgel published a paper in the journal Icarus called Directed Panspermia. Their argument was careful and almost heretical. What if life didn't begin on Earth? What if it was deliberately sent here, seeded across space by an older civilization that wanted to plant it on a young world? They were scrupulous about their own limits. They didn't claim it happened. They said only that it was conceivable and that the evidence wasn't good enough to judge the odds either way. But notice the door they opened, because an arrow that can point in can also point out. If a civilization could seed a distant world on purpose, then seeding is simply something technological life does, which means the role of the gardener isn't reserved for ancient aliens. It's a job description. The only question is who fills it. And the unsettling answer is that we already can. Consider what survives out there. In September 2007, the European Space Agency's Photon M3 mission carried roughly 3,000 tardigrades, microscopic animals, into low Earth orbit and exposed them directly to open space. The vacuum, the radiation, and when they came back, many were still alive. Some had survived not just the vacuum, but solar ultraviolet light up to 1,000 times more intense than what reaches the ground. Life, it turns out, doesn't necessarily die in the dark between worlds. Some of it just goes dormant and waits, and it has a way to travel. In 2013, Rachel Worth, Stein Sigurdsson, and Christopher House published a modeling study in astrobiology, tracing where Earth goes when something big hits it. When a large asteroid strikes, it blasts rock off the planet, and some of that debris never falls back. It escapes. Their models suggest that over about 3.5 billion years, a handful of Earth fragments could reach as far as Europa, Jupiter's ice-covered moon, carrying, potentially, whatever was living inside that rock. Put it together. Hardy life that survives space. Rock that flings it outward with every major impact. We may already be seeding the solar system, not on purpose, not with intent, but simply by existing on a planet that occasionally gets hit. So it was never one fact. It was all of them, pointing the same impossible direction. The universe is young, and we're among its first guests. The peak of all life may lie 10 trillion years ahead, which makes us the ancients. Life on Earth arrived the instant it could, fast and stubborn. Serious scientists argued life can be sent between worlds on purpose. Living things survive the void. Earth's own rock carries them outward. And on one November afternoon in 1974, we did the most deliberate thing of all. We aimed a transmitter at the stars and announced ourselves. That is the Firstborn Hypothesis. Stated plainly, not the latecomers, but the first ones. We've been playing the aliens part the entire time. We just kept facing the wrong way to notice. So do the thing you came here assuming you'd do. Go to a window tonight, tilt your head back, and look up at the dark, the way humans always have, waiting for someone older to speak first. Now hold that 1974 signal in your mind. It left 51 years ago. Tonight, it's more than 50 light years out, already past hundreds of nearby stars, still gaining a light year every year, and it will keep going for tens of thousands of years before it even reaches the cluster we aimed it at. You will never hear an answer. No one alive tonight will. Everyone you love will be gone. Every language you speak forgotten, long before that thread of human noise arrives. And that was never the point. Because the message isn't really the artifact. You are. Every probe we've launched past the edge, every microbe riding a blasted shard of Earth, every broadcast still climbing into the dark. Those are the ancient alien evidence of the future. They're being made right now, this decade, by us. We're alive during the universe's pre-dawn, and the relics a later cosmos will dig for, dream about, and search its sky to find are the ones our hands are leaving tonight. So here is the strange, quiet truth underneath the weight. The being you pictured out there, older, wiser, watching, ready to answer the call, was never going to step out of the dark. 10 trillion years from now, a mind that does not yet exist will point its instruments at the exact patch of sky you're standing under, and it will find the faintest trace of something that came first. It will call the thing ancient. It will call it the elders. It will wonder, the way you wonder now, whether anyone is really out there. And the ancient alien it's searching for is you, tonight, at the window, facing the wrong way, waiting for a signal that already left your hands.